Hello everyone. So in the previous presentation we discussed about the resistor and its types. And in this presentation we will be talking about the color coding of resistors. So basically, what is a color coding of resistors? Some resistors are really large enough to print its resistance value on it, but there are some resistors which are very small. So it is impractical to print its value on it. So we used the color coding method to find the value of a resistor. So basically this color coding is used for those resistors which are really small. For example, a thin film resistors of carbon or carbon composition resistors. A thin film resistor is shown in this figure, which has 4 bands of colors. These resistors are maybe of 4, 5 or 6 bands, depends upon the manufacturer. But first of all, we will be starting our discussion from the 4-band resistor, and then we will be move on towards the 5 and 6 band resistors. The first band represents the first digit, the second band represents the second digit, the third band represents the power of 10 multiplier, and the third band represents the tolerance of this resistor. And we will be find out the numbers which are associated to these colors by using the given table. So this table represents the color coding for 4-band resistor. Before going towards the explanation of this table, let me describe first these color bands, in which we have the first band and the second band represent the first and the second digits respectively. So from the given resistor, we have the first band which has a color of red, and from the given table we know that the number which is associated with a red color is 2. So the first number is 2, and the second color band is a violet. So the color which is associated with the violet color is 7. So the first statement was that the first band and the second band represent the first and the second digits respectively. So we can write down this 2 and 7 as a 27. And the second point states that the third band represents the power of 10 multiplied for the first 2 digits. So basically by this second point we means that how many zeros are follow this second digit. So the third color is a brown, so the power of 10 here is 10 raised to the power 1. So we can multiply it with the 10 raised to the power 1. And the fourth band shows the tolerance of this given resistor. By tolerance we means the range in which the value of this resistance lies. So fourth band is having a color of gold. So the tolerance of this is, from the given table we have plus minus 5%. So actually we define this tolerance as, so tolerance is basically the range of the resistor in which the resistance lies. So from here we get the value of resistance is 270 ohms with the tolerance of plus minus 5%. So by this tolerance we means that the range in which the value of this given resistor lies. So we need to find out the maximum and minimum value in which this 270 ohm resistor lies. So the 5% of this 270 ohm is 0.05 multiplied 270. We obtain 13.5 ohms. To find the maximum value, we need to add this 13.5 ohms to this 270 ohm. 13.5 ohm. So we get 283.5 ohms. And to get its minimum value, we need to subtract 13.5 from this 270 ohms. So 270 ohms minus 13.5 ohms. So we get 256.5 ohms. So from this tolerance value, we means that the 270 ohm resistor value lies between 283.5 ohms to 256.5 ohms. So the manufacturer guarantee that the value of this resistor lies between these two values, these two ranges. So in other words, we can say that a manufacturer cannot give you a resistor which have a rating of exactly 270 ohms. If this fourth band is of silver color, then its tolerance will be 10 plus minus 10%. If there is no color on the fourth band, then the tolerance is plus minus 20%. So it is very difficult for a student to remind this table. So different people use mnemonics to remember these tables. The mnemonics which I use to remember this table is, and this mnemonics is that BB Roy, good boy, very good woman. This mnemonics I use to remember the number of these colors. The first B will represent the black color, the second will brown, the R represent red color, O represent the orange color, Y represent the yellow color, and ignore these small letter words. Just look to this large letter words in which the G represent the green, B represent the blue, V represent the violet, G represent again the gray color, and W represent the white color. The black color is having 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So listen it again carefully. B. Roy, good boy, very good woman. I think it will help you to remember this table. So by using this procedure, the smallest resistor which we can color code from this procedure is up to 10 ohm. So if you want to extend this range, or if you want a resistor having value less than 10 ohms, then we need to insert a silver or a gold color as a third band. Because for a third band, the gold has a multiplier or 10 raised to the power minus 1, and a silver has a multiplier or 10 raised to the power minus 2. So let's consider if we have the same resistor, and if we omit this third band color and insert a silver color, let's assume here we have a silver band, then the value of this resistance will be, the first two digits are 2 and 7. The third digit is the multiplier 1, and we assume this third band is a silver band, and we know that the multiplier of this silver band is 10 raised to the power, multiplier of this 10 raised to the power minus 2, and its tolerance is plus minus 5%. So the value of this resistor will be 0.27 plus minus 5%. So if you want a value less than 10 ohms, then we need to insert a gold or a silver color as a third band. There is a question which arises that from where we start to code these color bands. So we need to start from the band which is closest to this lid. So in this figure you can see that the red one is more closest to this lid, and the gold is far away from this lid as compared to this red one. So this is a first band, this is second, this is third, and this is one. This one is the fourth band. So it's all for 4 bands resistors. Let's move on towards the 5 band resistors. So the procedure to find out the value of a resistor having a 5 bands are the same as we discussed in the 4 band, but here we have 5 band instead of 4 bands. So the first band represents the first digit, the second band represents the second digit, and we have here is the third digit, which is represented by the third band. So the difference which involves here in the fourth and the 5 band resistors is that there is a third digit in 5 band resistors. The fourth band will represent the multiplier of 10, or the power of 10 multiplier, power of 10 multiplier, and the fifth band will represent the tolerance of the resistor. So finding the value of this resistor, how much is the value of this resistor? So from the given table we have the value of red is 2, the first digit is 2, the second digit we have a blue color and the value of blue color is 6, and the third digit which has a black color and the value of black color is 0. So the fourth band will represent the power of 10 multiplier, and we have a yellow color. So the value of this band is 10 multiplies 10 raised to the power 4 from the given table. And the last one is the silver color, which represent the tolerance of this resistor. So we know that the tolerance of a silver color is plus minus 10%. So the value of this 5 band resistor is 260 multiplies 10 raised to the power 4 plus minus 10%. So it's all for 5 band resistor. So if a manufacturer wants to show the temperature coefficient of the resistor, then a 6th band will be included in this resistor to show the coefficient of resistance of this resistor. So let's consider if we have a resistor having 6 bands. So the procedure to find out the value of the 6 band resistor is the same as that of the 5 band resistor, but the only difference here is the 6th band which included in this resistor, which shows the temperature coefficient of this resistor. And basically the temperature coefficient of any resistor represents the rate at which the resistance of any resistor changes with change in temperature. So the first band represents the first digit, the second band represents the second digit, the third band will represent the third digit, the fourth band will represent the tolerance, the multiplier, the power of 10 multiplier, and the fifth band will represent the tolerance, and the sixth band will represent the temperature coefficient of this resistor. And the list of the colors which shows the temperature coefficient of the sixth band is this. A brown color has a temperature coefficient of 100 ppm per Kelvin, parts per million per Kelvin, and as the rest of the colors. So from the above table we determine the value of this resistance. So the green band has a number of 5, the blue band has number 6, the black band has number 0, and the red band has a multiplier of 10 raised to the power 2. And the fifth band has a gold color, so the tolerance of the gold is plus minus 5%. And the sixth band is a yellow color, and it shows the temperature coefficient of this resistor, which has the yellow color has a temperature coefficient of, we can say that the temperature coefficient of this resistor is 25 parts per million per Kelvin. So if you want a tolerance less than 5%, then the brown color has a tolerance of plus minus 1%, red color has a tolerance of plus minus 2%, green color has a tolerance of plus minus 0.5%, and blue color has a tolerance of 0.25%, and the violet color has a tolerance of plus minus 0.1%. So if you found a color other than silver or gold, then this table might be useful to find the tolerance of the resistor. So it's all for today's lecture. In the upcoming video, we will be talking about the voltage and current relationship for resistors. So see you in the next one.